It will all be made apparent. I think this is going to work out well. Okay, so this actually is the lecture slides. So, did you bring your lecture slides? No? No? Do you want to go ahead and get a minute? That sounds good. Oh, are we ready? But I just think this is a good way to end Chem 2, because in Chem 1, you talked about balancing equations with the, by inspection, I said use a pencil because you need to kind of go back and forth. This is another way to balance chemical equations, but they have to be reactions that are redox reactions, okay? So there's some steps here, and as I go through lab, I already kind of told you, because Dr. Snipes told his class that we have the same final, that on the final, one of the problems you can do at the end is one of these. So if this works for you, then there's one of your, 8 problems or something. Okay, so the first step, or this isn't necessarily a step, this generally says that we're dealing with redox reactions. Something's going to be oxidized, something's going to be reduced, just like we were talking about in lecture, and that oftentimes the reaction is just written with an equation in its net ionic form. The spectators are removed. So now we're kind of getting on into the steps. I think step 1 is to come up with 2 half reactions. So you have a reaction of interest. It's not balanced. That'll be the top. And then you have to break it into 2 half reactions. 1 half reaction, you're going to show something being oxidized, an atom being oxidized, but what will come with it is the thing it's in, the whole reactant, okay? And then you'll have another half reaction, and when we get started here, it's going to be kind of columns. So you'll have a half reaction here, a half reaction there. One will be where something's oxidized, and remember we said that if something's oxidized, that means that its oxidation number is going up. But actually, kind of then also on the product side, think of electrons being released, okay? So its oxidation number goes up, electrons are released. But the thing with the reduction, think of electrons on the reactant side. So basically, electrons react with something, and its oxidation number goes down, okay? So it kind of works, I think, gaining of electrons. So basically what we're going to see is you'll have 2 columns. You only have the reaction of interest that needs to be balanced, 2 columns, okay, for a long time, and then we'll come together as the balanced reaction at the bottom. Yeah. So I guess we aren't necessarily at a step. So today, if you've had a chance to kind of look at the lab, okay, part 4 goes along with the lab. And we're going to balance them in acidic solution, and then we're going to switch gears and balance them in basic solution. So you guys know if a solution is acidic, it has extra H pluses, okay? When we switch gears, we're going to balance it in basic solution, it has extra OH minuses. Okay, so starting with acidic solution. This is the steps. This is what, I thought it's step 1. This is like the sort of thing I might put on my note card, or for you guys, it's a whole sheet, right? I might put on my sheet. First, you're going to separate it into 2 half reactions, okay? And the cool thing is you don't necessarily even need to know which is which. You're just going to basically have 2 columns. So that's cool. And we're going to do one example, okay? And then we're going to do one example, and there's a second example I'm going to give you a hard copy of. And then you can actually do it for lab credit on your own. So you separate it first, okay? The next thing you're going to do in both of your columns, both of your half reactions, is you're going to balance everything. You're going to use stoichiometric coefficients, change the coefficients from 1 to whatever they need to be to balance everything except for hydrogen and oxygen. That's step 2. Step 3, you go ahead and fix your oxygens. Again, it's each half reaction by itself. You're going to, if you need oxygen, you're going to add it to whatever reactant or product side it needs to be added in the form of water. Okay, so that's where your oxygen is coming from H2O. That's step number 3. Step number 4 kind of fixes the whole adding water. Step number 4 says, all right, let's go ahead and look at your 2 half reactions separately, and we're going to add H pluses to go ahead and balance your hydrogen. Okay. That's step number 4. Step number 5, now you get to look again just at each half reaction separately, but kind of take a look at it, and it's going to be on either side of the reaction arrow, probably lopsided with regard to charge. Every H plus brings a +1 charge, okay? And so the deal is you will get both sides of each half reaction equal by adding electrons, cute little E minuses, okay? So, for instance, if you have an H plus over here, okay, and it's neutral over here, we could add one E minus, one electron over here. That would make that neutral, and it's neutral to neutral. Okay, so that's kind of how that works. All right. Then what you do is you finally start to kind of look at both half reaction. Okay, basically you're going to have electrons released in the oxidation part and electrons consumed in the reduction part. But they're probably not the same number of electrons in both half reactions. So here's where you're going to have to scale up one reaction to equal that same electrons, or find the lowest common multiple and basically scale both of them up so you have the same number of electrons released as gained. So here you're actually taking a bird's eye view at both half reactions. And then hopefully you cross your fingers, all right? You have 2 half reactions down here at step number 6. Step number 7 is to do a Hail Mary and basically add them together, okay? You're going to add your 2 half reactions. You're going to let things cancel that will cancel. That includes electrons and protons, that's H pluses, and water molecules, okay? That is actually hopefully going to be your balanced equation, okay? So that's step number 7. Step number 8 is to trust but verify. No, Reagan, right? Step number 8 is to go ahead, and if that is your balanced equation that you've done by the half reaction method, that redox reaction, it needs to be balanced for mass. That simply means the same number of hydrogens and oxygens and chromiums or whatever on either side of the reaction arrow. And it needs to be balanced for charge. So again, if it's not neutral on one side, then it has to have the same charge on the other side of the reaction arrow. All right, so here we go. Now, I have these. Do you guys have these too? They're teeny tiny. Very good. Awesome. I'm going to take you through steps 1 through 8. Okay? So before I do that, let's go ahead and do a step up here, kind of like we were doing in lecture. Okay? Let's come up with oxidation numbers for the CR, the O, and the I. Okay, so for the dichromate, CR2O7, okay, I don't know what the chromium is necessarily, but I know that the oxygen is what, -2. -2. Okay, and there are 7 of them. Oh my gosh. So -2 times 7 is -14. Okay, and the charge means that it's going to have a net -2, so basically that's -12, right? So plus 12 must be those 2 chromiums, so plus 6 for each chromium. Okay, just kind of doing it in our head like that. The I minus is oxidation number -1. The chromium +3 is +3. And, ooh, we have that triiodide polyatomic ion. So we said, remember that basically we're going to take the -1 and divide by 3, so it's -1/3. Is that not fun or what? So if we were going to kind of draw some links here, it looks like the chromium is being reduced. Okay, and it looks like, goodness, a -1 to a -1/3. I know it's kind of strange, but this is being oxidized. I'll put an OX for the iodine and an RED for the chromium. Okay, so you don't necessarily need to know all that, but where I've drawn those purple arrows, those actually are what we're going to pick out, and those are going to be our 2 half reactions. So I think it's kind of helpful. So here's our 2 columns, okay, and our 2 half reactions. That's step number 1. We've separated them. Step number 2, Oh, let's just do this one. Check this out. I didn't know you guys had those. Oh, is this right? No, it's a different. Oh, these aren't those. Okay, so step number 2 is to balance them for anything except for oxygen. So can you see on this half reaction that I got to balance it for chromium? Okay, and it looks like I have to balance it for iodine over there. So that is step number 2. Okay, so I put a coefficient of 2 in front of the Cr plus 3, and I put a coefficient of 3 in front of the I minus. I know it seems kind of strange, but. So the next step is to fix the oxygens. So it looks like I don't have to do anything with my, my right half reaction, but my left half reaction, I need to get 7 oxygens on the product side. So I get 7 oxygens on the product side by adding 7 waters. Okay, so basically we just kind of bring it down, add 7 waters, fixing the oxygen, and notice on the right one, no oxygen needs to be fixed there. So step number 4 is to fix the hydrogens. Remember, this is an acidic solution, so we need to fix the hydrogens that were introduced by those 7 water molecules by what? Adding 14 H pluses over on the reactant side. And it looks like we don't need to fix any hydrogens over here for the right half reaction. Then we're ready to balance for charge. So let's take a look at charge here. I'm going to kind of refer to the bottom one. So again, it seems kind of strange, but can you see where I have a -2 and a +14 here? All right. And so by my account, that is what, a +12? That's what we have on the reactant side. Over here on the product side, it's looking like 2 times +3 or +6, okay, and nothing for the water. Okay, so I have a +6 over here. So do you see where I need to tap down this is too positive over here. And the way you tap that down is to add electrons. So I'm going to add 6 electrons over here. Let's go take a look at the last time we had to do anything with this half reaction. Okay. Do you see where it looks like I have a -3 on the reactant side? Okay. And a -1 on the product side? To me, it's looking like I need to what? Add 2 electrons over there. Does that make sense? So that's kind of how that goes. Okay, so we added 6 electrons. And why did we add 6 electrons? Because I looked on either side of the reaction arrow and saw that it was, what, +12 and +6. So I can bring it down. And we added 2 electrons over here, and why was that? Because I had a -3 and a -1, so I had to bump up the negative on the product side, so I could do that by adding 2 electrons. Now, the next thing is to get the electrons that are released equal to the the electrons that are consumed, because that's what's being consumed over there, equal to the electrons that are released. So if I scale up this right one, if I scale it up by what, a factor of 3, then I can get 6 electrons released. And that's exactly what I'm going to do. Okay, so I'm going to leave the first one alone. I'm going to have 6 electrons consumed and 6 electrons released. In scaling it up, I needed to multiply through by what, a factor of 3. So that 3 in front of the I turned into a 9. That 1 in front of the I3 minus turned into the, that 3 in front of the I minus turned into a 9. That 1 in front of the I3 minus 1 turned into a 3. And of course, the 2 electrons is now 6. Yay! And we're getting very close. So 7 is combine and allow to cancel. So if you want to rewrite this, you could, basically kind of centering them both on the reaction arrow. Okay. Or just kind of bring the mess down for this other step. I guess that really works. So I haven't canceled things yet. That's coming here in a minute. But this actually is the left half reaction. Okay. And this actually is the right half reaction. All right. So allow things to cancel. Cancel and combine. Of course, our electrons have canceled. It's looking like that might be about it. Okay, cancel what you can, combine what you can. Sometimes the H pluses will combine. Sometimes you'll have water molecules kind of canceling. But for this, it looks like this would be your overall balanced equation in acidic solution for this redox reaction. So step 8 is to check it for charge and for mass balance. The charge is kind of like what we did before. So like if I was checking this for charge, I'd have a -2 and looks like a +14 and a -9. So let's see, -11, so that's like +3. Let's check out over here. It's looking like a +6 and a -3. Okay, or a +3 here. I mean, some people can do that in their heads. I have to write it down. So that's how that works. So the charge looks great. And actually, we have the same number of chromiums. Let's check it. We have 2 chromiums over here, 2 chromiums over here. Oxygens, it looks like we have 7 and 7. Hydrogens, we have 14 and 14. And iodines, we have 9 and 9. So that all looks good. Ding, 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 ding. Okay. So that's step 8. Make sure everything looks fine. Any questions about that? So here's your opportunity. There's a slide like this after we talk about balancing them in basic solution too. So what you would need to do if you wanted 5 extra credit lab points, okay? And there's 5 coming in the next slide too for a total of 10. So basically, this is not a lab. This lab will not exist in the grade book, okay? But if you work just these 2, okay, if you work C and D, okay, and hand them in and they're right, and you can know, the beauty of this is you can check if they're right or not. Then you can get 5 extra credit points that goes to labs, not assignments to labs, which, like I said, is kind of different for me. And in your lab are some worksheets, some blank worksheets that you can use. I would suggest you just use those for C and D if you want. You know what I mean? Like in your lab, for this lab. Okay? So let's take a look at basic solutions. Yep, I would just, you can fill them in, yep, and you can even tear them out. Yep. But like I said, if you're wanting to work this problem on your final, I would write down some steps because I always forget. Okay, but doing them will also help.
So are we going to have to know if it's like in an acidic solution or basic solution?
I will tell you that, yeah. Someone would have to tell you that. On a problem that needs to be worked, they'd have to tell you. So we'll have to
just like look at the elements and compounds and know that it'll be provided.
Right, yeah. Somebody would say if it's have excess hydrogen ions or excess hydroxide ions. Yep. Yep. So I guess you need to be prepared for either one. And the cool thing about it is actually what I need to show you next with it being in not acidic but basic solution is very similar. Okay, it kind of deviates at one point, but it's very similar. So if it's in basic solution, one of the things that we can't have is those little H pluses running around, so we need to fix that with eating them up with OH minuses, basically. Okay. So you can see this last bullet here. what you're gonna see is that we're gonna first balance them for mass and charge, and then we're gonna add on to that. Before we add them together, okay, we're gonna add something onto that. So here we go. Steps 1 through 5 are the same. Just to remind you what they are, steps 1 through 5 are. You separate them into 2 half reactions. I think it's kind of nice to put little oxidation numbers so you know which ones go with which. Okay. And then you use stoichiometric coefficients to balance everything except for the hydrogen and oxygen. Then you balance the oxygen by adding water as needed. And then you balance the hydrogen by adding H pluses as needed. Okay. And then you go ahead and do the little checking on either side of the reaction arrow what your charge is and add electrons as needed to each half reaction. Okay, so that's going to be the same in the example. Step number 6 then, if it's in basic solution, okay, is this. Step number 6 says, all right, wherever you have H pluses, which you probably do, because you need to add the hydroxide ion. But, and this makes sense, I was like, you can't, it's just like working a problem in math. You can't just add OH minus to one side. You have to add OH minus to both sides, okay? But the cool thing about if there were hydrogens over H pluses over here, you add OH minuses, they're going to annihilate each other and make water. Over here, you're going to have leftover OH minuses. That's kind of how that's going to go, okay? So this kind of, step number 7 then, if it's in basic solution, is to go ahead and clean it up. Make water out of your H pluses and OH minuses, and of course your H2Os will be allowed to be what they are. So at that point, with getting to step number 7 here, you're basically back at balancing it with regard to mass and charge. And step number 8 then is kind of familiar what we did in acidic solution. Step number 8 finally is to look at the number of electrons that are consumed and the number of electrons that are released, and you need to make those electrons the same. So in our case, we ended up scaling up the right one to get 6 electrons. So just do what it takes to get the same number of electrons consumed and released. And then step number 8 is that Hail Mary. Sorry, step number 9 was step number 7 before. Step number 9 is to go ahead and add them together, you know, centered at the reaction arrow, and collect what you can and that sort of thing. And then the last step is going to be, after you've cleaned it up, make sure that it really is balanced, is verify your work with regard to charge and mass, which just means the same number of atoms of each type of element on either side of the reaction arrow. All right, example. Looks like hydrogen peroxide and chromium 3 hydroxide. So let's do what we did before. Let's go ahead and add cute little oxidation numbers at the top there. So let's see, how's this one? What did I say before? I'm trying to remember, I'm drawing a blank. I said that +1, now this actually is a peroxide linkage, so oxygen is not -2, oxygen are each -1. Usually you can hang your hat on that not being, that oxygens are -2, but this is hydrogen peroxide, H2O2. Over here with regard to the chromium 3, so we'll go ahead and put a +3 over the chromium. And here for the OH minus, that hydroxide, water is behaving itself. It is a -2, and hydrogen is a +1. Over here on the product side, hydrogen is a +1, oxygen a -2. The chromate ion, let's go ahead and put a -2 for the oxygen. And let's figure out what the chromium must be. So -2 times 4 is -8. It needs to run around with a -2 charge, so that's -6 basically. So to me, this is the +6 in my own little brain. So if we kind of pair up what's doing what, it looks like the chromium for sure is being oxidized, going from a +3 to a +6. Okay, and in this case, actually, it looks like the oxygen is being reduced. The oxygen in the peroxide, okay, is being reduced from a -1 to a -2. RED. And if you're like me, well, maybe it's the oxygen in the chromate, but we're going to go with that. I think that will work real well. So our two half reactions look like this. H2O2 going to form H2O, and again, it's the oxygen going from a -1 state to a -2 state. And here we have chromium going from a +3 to a +6. But you don't need to know that. You just need to identify what your pairs are. So then we said balance for everything except for hydrogen and oxygen, and that doesn't apply there. And actually, that doesn't apply here either. Does that make sense? There's nothing to fix except for hydrogen and oxygens. Then we're going to fix our oxygen by adding water. So it looks like we need to add 1 water molecule over here. Okay, let's see, 3 oxygens, 4 oxygens. Looks like we need to add 1 water molecule over here. Okay. Then we need to go ahead and fix our hydrogens. So it looks like we've got 4 hydrogens versus 2 hydrogens. We need to add a couple hydrogens there. Looks like we've got 3 plus 2, we've got 5 hydrogens here. Wow, looks like we need to fix and add 5 hydrogens over there. 2 hydrogens there and 5 hydrogens there. Now's when we are going to go ahead and balance for charge. So let's take a quick look at what we got. Let's see, charge-wise, looks like I've got a +2 here, and we've got a 0 here. Okay, so to make it 0 over here, it looks like we're going to add 2 electrons. Looking at the other side, looks like we've got, wow, 0 over here. That's kind of fun. We've got a -2 plus 5, or a +3 here. Okay, so in order to make that +3 go to a 0, looks like we're going to have to add 3 electrons there. Okay, so added 2 electrons over here and added 3 electrons over here. So if you remember, after you get the electrons balanced, that's where you deviate, I'm pretty sure. That's where we're going to come out now, and we're going to fix our hydrogens, and we're going to add OH minuses to make them go away. Okay, so notice, how do we make our hydrogens go away in this left one? Okay, well, we have 2 H pluses. So we need to add 2 OH minuses to both sides. Of course, on the reactant side, those are going to combine to be water, and on the product side, it's going to stay as hydroxide. Fixing the right half reaction, we needed to add 5 hydroxides to fix those 5 H pluses on the product side. Okay. So step number 7 is to go ahead and combine things that combine. So of course, our H pluses and our OH minuses turned into water, okay, over there, and they turned into water over here. We're close. This is the Hail Mary part, right? So step number 8 then is to go ahead and center them on the reaction arrow and add them all together. No, it's not. Almost. This is just kind of a continuation of step number 7. Just kind of cleaning things up, which is a good idea. Notice, if you look at the left half reaction, what was done was to, darn it, make those things go away. we need to balance for charge in the 2 half reactions next. And similarly, kind of, oh yeah, I've got a thing this. Okay, they went away, and over here, now remember how this works? Since we had 5 on the product side and 1 on the reactant side, that 1 on the reactant side could go away, and that diminished the 5 to a 4 on the product side. Remember how that works? So I got ahead of myself. Not time to add yet. You know what it's time to do is to make sure that these electrons, the electrons what consumed are equal to the electrons that are released. Well, we don't have the situation of scaling something up and then both being equal. Instead, can you see where if we scale them up to be equal to 6 electrons, that's the route to go. So basically, if we scale that up to, multiply everything by 3, we get 6 electrons. Multiply everything here by 2, we get 6 electrons. And that's exactly what you're going to see in the next stage. Okay, so multiplying through by 3, okay, we get those new stoichiometric coefficients. Multiplying through by 2, we get these set of stoichiometric coefficients. And the reason we did that is before we add, we need to make sure our electrons are going to cancel. So that doesn't look too bad. So step number 9 is to add them together. Step number 10 will be to verify. So adding them together, they look like this, where here, these right here are the left reaction. Oh, mental block. And these right here are the right half reaction. So make sure things that will cancel. So this is my favorite part. Okay, so 6 electrons go away on both sides. It looks like we can clean up our hydroxide. Okay, so it looks like all of these 6 will go away and leave that with a 4. Does that make sense? That might be about it. Yep. Okay. So rewrite it, and this is what you get. That's step number 10. Well, I guess 10 is to verify. So let's take a quick look at charge on either side of the reaction arrow. So it looks like we have a -4 over here, and a 2 times -2, -4 over there. So that's all works. Okay, and it looks like we have, these are no fun. So hydrogens, of course we have 6 hydrogens plus 3, 6. We have 12 hydrogens plus 4, oh my gosh, 16 hydrogens. Okay, over here we have 16 hydrogens. And oxygens, we have 3 times 2 or 6. And oxygens here, we have another 6, so that's 12, plus another 4, that's 16 oxygens as well. We have 8 oxygens from here and 8 oxygens from there, so that's 16. Chromiums, we have 2 chromiums and 2 chromiums, and that should do it. So, looks good to me. Any questions? Okay, so instead of C and D, these are A and B, just because it was easier. So for 5 points, and again, the sheets you have in your lab notebook have acidic and basic. So it's worth it, you know. Like if you missed a point here and there, it'll backfill those points too. Maybe 10 points just to kind of either be a whole lab that you didn't do or didn't have turned in, and then also it just fill in miscellaneous points. So these are, let's take a look at these. These aren't what I thought they were. These are actually examples, other examples. So you can kind of use these a couple different ways. One is to work them, okay, and then see how you did. These could be practice ones. Or I guess that's probably, or don't work them, just kind of look and say, oh, well, that's how they did that. You know, it's acidic solution. These are the 7 steps they did. So that's kind of how that goes. Any questions? So are you guys okay if we don't take a break and we just kind of keep going on to the next thing we need to do? Or did you want to take a break?